Today's topic is city planning. When city improvements and new developments occur without thoughtful foresight and planning, the development tends to occur in a piecemeal fashion, and buildings are designed without full consideration for overall urban design and aesthetics, as well as potential impact to other interests. This is a big concern for city authorities. If a planning department doesn't become proactive in this regard, fundamental issues will fester and continue to grow. Today, we're going to show how planning authorities can understand the aesthetic nuances of introducing a new building into a cityscape, or even updating the footprint of an existing building. This approach can be very beneficial to the planning process and can be used to engage various interest groups beforehand as part of the overall strategy to ensure full disclosure, complete understanding, and best reception for new projects. At this point, I'm going to turn it over to Robert Gammon, who will demonstrate how to remove an existing building from a cityscape and, in turn, replace it with a new rendition of a planned building.
As a starting point, we have a cityscape of the downtown area in Indianapolis. This data was created and provided by Pictometry. As you can see, there are a large number of buildings in this scene. However, we want to replace this building here with a new building. Before removing this building from the cityscape, let's use the illumination commands to gain a better understanding of the existing shadows. The illumination commands can be used to toggle the sun on, cast shadows, and set the time of day. Notice that as the date time slider is used, that the length of the shadows in the entire scene dynamically update. More specifically, have a look at the length of the shadows cast by our soon-to-be replaced building. These are relatively small given the current height. It is important to note that all of the buildings in this scene are represented by a single 3D mesh model, and therefore removing a single building requires a surface modification step. To modify the 3D mesh surface in a specific area, we need an area-based feature class. In this case, we'll use the feature called flattening area. Once this feature has been toggled on, we can see that it forms an outline around the building we want to replace. As with all feature classes, we can stylize this entry. In this example, we use the Properties button to access the 3D Settings tab. With the 3D Settings tab displayed, we can use the Replace With option. This option contains 5 choices: 3D Object, 3D Mesh Layer, Point Cloud, Viewshed, and Modify Surface. The Modify Surface allows us to replace the 3D mesh layer or an existing terrain with a modified surface in targeted areas. In this case, we're going to use it to flatten a building and thereby remove it from the cityscape. The Modified Surface option works in tandem with additional options found in the Advanced tab. As we scroll down, notice the Surface Elevation Mode, Surface Feather, and Surface Flat modifiers. For now, we're going to make use of all the default values for these modifiers. However, the most important aspect of this workflow is the area feature class used to represent the area to be flattened. The area feature must include Z values. These Z values are used as input and drive the surface modifiers Replace Elevation, Crop Elevation Below, Crop Elevation Above, and Offset Elevations. In this case, the Z values were encoded when the area feature was digitized while in 3D. Most notably, when features are digitized in 3D, they are encoded with the elevation value at each of the vertices. The foundation of the building to be replaced lies at approximately 710 feet above sea level, and hence the Z values reflect this elevation. Notice that as soon as the OK button is clicked, the building is removed from the scene and the shadows update automatically. With the old building removed, we can replace it with a simplistic rendition of the new building. This rendition of the building is made up of a small collection of 2.5D polygons. This feature class has been stylized to extrude to the height of each of the Z values and hence create a 3D representation of the proposed building. Notice again that the shadows update to reflect this rendition of the new building. Finally, we can remove the simplistic rendition of the building and replace it with a higher quality representation, one that includes higher fidelity geometries and higher quality textures. This model was created in SketchUp and imported into GeoMedia 3D using the import utility.
Thanks, Robert. That was a really great example of how GeoMedia 3D can be used for truly informed city planning. After seeing the 3D view of the building change, it would be really hard to go back to top-down views. After all, the world's not flat. Why view it that way? That concludes the demonstration on GeoMedia 3D city planning. Thanks for your time, and have a great day.